everyone, before we go on, kind of an addition here to the end of 5.3. Integral symmetry. So this does not come up specifically in our textbook, but it's definitely worth mentioning here when we're first learning the fundamental theorem of calculus. Occasionally, this is kind of going to come up a little bit, even more so when we get on to chapter 6 and some of those things to take advantage of symmetry. So we're going to talk about two possible symmetries. The first is if f of x is an even function. If you remember, an even function means it is symmetrical over the y-axis. It's got a mirror image, you know, kind of that way across the y-axis. If you had an even function and you were taking the integral from negative a to a, so even the limits of integration are symmetrical over the y-axis, then what you could do instead is say, you know what, when I plug my numbers in, instead of plugging in a and negative a, I can get away with just plugging in a and 0. Just take the integral from 0 to a, but then double it. And that might make your calculations a little bit or even a lot easier. Let me show you what that looks like graphically. Just pretend that my drawing is symmetrical over the y-axis. It's pretty close, right? So imagine that's the area we want to find, right? F of x is an even function. It's got that symmetry. And we're looking at the definite integral from negative a to positive a. You think, well, you know what? These two areas are identical because of the symmetry. So why don't I just find the area from 0 to a and then multiply by 2? And that would give me the total area that I was after. That could make my work a lot easier. Okay, so watch out for that sort of thing. The other type of symmetry, what if f of x is an odd function where it's symmetrical over the origin? So symmetrical over the origin would mean if you took it and rotated it 180 degrees, it would look the same. We'll see a picture in a second. If it's an odd function and you're integrating, say, from negative a to a, you would end up with 0. So this isn't going to come up a whole lot, but if it ever did, it would really be to your advantage to be able to spot it. What does this look like? All right, there's an odd function. It's symmetrical across the origin, which means if you were to rotate it 180 degrees, it would look the same, like spin it. Why would that definite integral be 0? Well, because these are they're identical shapes. The regions, the areas there are the same. And, you know, below the x-axis is negative area, above the x-axis is positive area. They would exactly cancel out and we would have 0. Again, this isn't going to come up a whole lot, but if it did, it might be nice to be able to recognize that. Okay, that's it for symmetry. See you in the next one.